Hi everyone, welcome to Chapter 14, Part 1, Reproducibility and Replication. So we're going to start this by asking a review question, just stuff we've talked about in previous chapters. Which one of these do you not worry about if you get significant results? If you get significant results, don't worry about this one. If you get significant results, don't worry about ceiling effects, because ceiling effect is only an explanation when you have null results. Essentially, it's an explanation for why you may have made a type 2 error. Design confounds, carryover effects, and observer bias are all explanations as to why you might have made a type 1 error, or a type 1 error. Okay. So what we need to talk about is replication or reproducibility. We're talking about replicating the findings of a study. So think of an experiment, for example, and trying to replicate its findings later on. Replication, also called reproducibility, is a major component of the scientific method. The idea is that you get the results not just once, but again and again, if you have the right conditions and everything else. Now, recently, by recently I mean the last 10 years, psychology has had what's called a reproducibility problem or a replication crisis. There's been a lot of studies that have found that we are not doing a very good job at doing this. But to give you an idea of what replication is and how it's important, let's go ahead and do our own example. So here's what I want you to do. First, tell me whether the last digit in your phone number is odd or even. So, for example, if the last digit in your phone number is a 7, then it is odd. If the last digit of your phone number is a 2, it is even. Treat a 0 as an even number. Okay, you told me that your last digit of your phone number is odd. What we're going to do is we are going to do a study, and this study is to help us understand better how people function when they don't have certain mobility options, mobility abilities, right? So, for example, if somebody was quadriplegic, that means that they couldn't use their arms or their legs. And so what we're going to do is we are going to have you do an experiment, and I'll show you what we're going to do, but you can't use your arms or your legs. So you'll need a pen or pencil and a piece of paper for this. And what you're going to do is you are going to do this entire thing with your pen in your lips, like this. You're going to write, but it's important that you keep your pen in your lips. Don't let your teeth touch your pen. Okay, you have indicated that the last digit of your phone number is even. So what we're going to do is we're going to do a study that has to do with mobility and trying to empathize with people who have limitations in their mobility. Specifically, we want to do this as if you were quadriplegic. That means you can't use your arms or your legs. So what we're going to do is you'll need a pen and a piece of paper for what we're about to do. But what we're going to do is I'm going to have you write on the piece of paper not using your arms or your legs. Instead, you've got to put your pen in your mouth. And specifically, I need you to put your pen in your teeth, like that. Okay? So you're going to write with your pen in your teeth. Don't let your lips touch your pen. And I'll tell you what to do. So with this empathy study, here's what we're going to do. We are going to look at 3 cartoons, 3 Calvin and Hobbes, in the newspaper cartoons. And you are going to put your pen in your mouth, like I told you, and you're going to rate how funny you think the cartoon is. Okay? So you can only write with your pen. And then if you need to move the slide along, you can actually use your fingers for that. But only write on your paper using your pen in your mouth. Okay, here we go. Okay, rate this cartoon. 1, least funny. 5, the most funny. Remember, put your pen in your mouth to do the rating on your piece of paper. Second cartoon. All right, again, write down your answer on the piece of paper, doing 1 and 5. Last cartoon. Okay, give this one a rating. Now, look at your scores that you wrote down on the piece of paper and tell me what your average was. All right, thanks for doing that. This is a replication of a study that was done by Strack and Strack's colleagues in 1988. This is based off what's called the facial feedback hypothesis. And the idea is that your facial expression will affect your humor or your, liking, your enjoyment of something, your emotion. So what we did is you were either put into one of two groups. You were put into a group with your pen in your mouth, meaning the pen was only in your lips. Or you had the pen in your teeth, like that. So what happens is when you have the pen in your lips like this, it uses all of the same muscles as a frown. When you have the pen in your teeth like this, it uses all the same muscles as a smile. And then you look at the cartoon and you rate the cartoon. Okay? When they did this, they found that the people who had the pen in their teeth rated the cartoons as significantly funnier. They enjoyed the cartoons significantly more than the ones who had the pen in their lips. Now, every time I have done this as a replication over the last more than 10 years, I've never had it work. I've never seen a difference. Even though I've used hundreds of students at a time, I've never seen a difference between the pen in the mouth, meaning the pen in the lips, and the pen in the teeth. Okay? The question is why? Why didn't it work? Why hasn't it worked for me? Just so you know, this particular study has been one that's been difficult to replicate, not just for me, but for other people as well. Well, the question is, what's going on? Somebody must have made an error. So let's assume that Strack et al. 1988, the first study that was done is the first study, and then when we did it in class, that's the second study. One of us must have made an error. One of us had to have made an error. Either Strack et al. Made an error when they said that, hey, changing your facial expression by putting the pen in your mouth that specific way, by making that facial expression either sadness, happiness, or sadness, will change your emotions. They were either wrong about their conclusions, or we were wrong when we did a replication. Okay. Originally, they rejected the null hypothesis, so they could have either been correct or made a type 1 error. We failed to reject the null hypothesis, so we could have been correct or made a type 2 error. Either way, one of us had to have been wrong, right? In reality, changing your facial expression either does or does not change your humor. And since we came to different conclusions, somebody must have been wrong. Well, why? What happened? Why didn't it work? Who was wrong? This is an important part of trying to figure out how to replicate and figure out how to do your studies, especially when you're doing replication studies. When we do this, it could have been that originally Strack and Deutsch were actually wrong. They didn't actually find that facial expression changed humor. Instead, they could have had systematic variability. That is, that people who had the pen in their lips were in significantly more pain than people who had the pen in their teeth. That would account for the change in the humor, for example, right? If they did that, then they would have made a type 1 error. It wasn't because of facial expression affecting humor. It would have been pain or something else. Or it could have been that when we did the replication, we didn't actually effectively manipulate facial expression the way that they did. Or there was something else that we did in the way that we did our ratings that wasn't correct. Or perhaps there's some other form of noise or unsystematic variability that's accounting for our null results. And we don't know. We don't know why we didn't replicate, but over time, if things are true, if they're true relationships, then we should see replications. We should see replications, even though sometimes there will be error in any study. So to do a replication, you can either do a conceptual replication or an exact or direct. Exact and direct replications are the same. Let's talk about exact and direct replications first. An exact or direct replication is exactly that. You do the study exactly the way they did. Exactly. Now, in our replication, we didn't do things exactly the way they did. We actually changed a few of the operationalizations. And so a conceptual replication keeps the concepts like facial expression and humor, right? Those conceptual variables, but they'll have different operationalizations, different manipulations, or different measurements of the dependent variable, okay? So a conceptual replication keeps the conceptual variables the same, but changes the operationalizations. An exact or direct replication keeps everything the same, the operationalizations as well as the conceptual variables. The good things about an exact replication are that you can make sure that you do things exactly right? You keep everything the same. But a conceptual replication is often very nice because it starts to eliminate some of those problems that may have happened if your operationalization was incorrect. You had bad construct validity, which led to a confound, which led to poor internal validity. Perhaps if we use conceptual replication, we can say, hey, it wasn't the independent variable that's causing the change in the dependent variable. Instead, it's just systematic variability of the way you did your study. Studies that involve replication include other things as well. So for example, a replication with extension is when you would replicate a study, but you would add a new variable. That's the most common way that you would do a replication with extension. You extend the study by adding a new factor, for example. That would be a replication with extension. A meta-analysis is not a replication with extension. Instead, what it does is it takes many different studies about the same conceptual variables and puts them together to see what the overall effect size is for all of them. So instead of actually doing a direct replication or even a conceptual replication, it takes all of these replications, puts them together and says, even though this one study did not reject the null hypothesis, all these studies overall do see a relationship between the independent variable and the dependent variable. Okay, we're going to finish with just a couple of review questions. A direct replication is the same as a conceptual replication, true or false? That is false. A direct replication is the same as an exact replication, but direct replications replicate both the operationalizations as well as the conceptual variables, and a conceptual replication just replicates the conceptual variables with new operationalizations. A replication with extension is the same as a meta-analysis. This is also false, right? A replication with extension is a new study where you add in a new factor, whereas a meta-analysis takes old studies, puts them together, and statistically finds the effect of one variable on the other. Okay, thanks everyone. Okay, welcome to Chapter 14, Part 2. We're going to continue talking about problems with replication and how to do replication. The first thing we're going to do is we're going to watch a YouTube video and ask a couple of questions about this video. All right, now that you've watched that video, I need you to tell me, is replication a problem only in psychology? This is false. Replication is a problem in many branches of science. As we saw in the video, many branches of science are having trouble replicating specific studies in the way that they intend to. P-hacking is most related to which one of these? This is a problem with statistical validity. P-hacking is when you do your study in specific ways that make it more likely for you to get a p-value that is less than 0.05. Now, many times this is unintentional, okay? Many times p-hacking is unintentional. It involves, for example, going and starting to do your study, then looking at your data about halfway through and say, oh, we're really close, and then adding some more participants. Looking at the data again, oh, we're really close again, and then adding more participants again until finally you get it where the p-value is less than 0.05. You shouldn't do that. You shouldn't do that. You should have that ready to go beforehand because that's not the way p-values are supposed to work. Another way to p-hack is by doing lots of different statistical tests. The problem with that is that you're more likely to get a false positive if you do lots of different studies. Remember, p is less than 0.05, so you'd have a like 5% chance of getting something when the null hypothesis is true. Well, if you do like 100 studies, then you would expect at least 5 of those to happen when the null hypothesis is actually true. So the more studies you do, the more likely you are to get a result that's going to lead you to a type 1 error statistically. So p-hacking is something that people do, and often it's not intentional, but it's something that they do statistically where they end up with more statistically significant results than they should have based off of their study. All right. Other people are not convinced that there really is a crisis. So, for example, this link leads us, and I'll show this to you, to this article right here. This is about a refutal or a rebuttal against the reproducibility project. And it's written by Dan Gilbert, who's a very famous psychologist from Harvard. In fact, he's the one who's on the Prudential commercials as a psychologist, right? But he's talking about how he believes that those statistics weren't done correctly. And then there's a counter rebuttal from Nozick, who says that, no, that's not true. We did it right. You did it wrong, etc. So there is a debate as to whether or not we truly are in crisis as a discipline in being able to reproduce our projects. Many people say that we do have a problem, and then other people say that we don't. Regardless, reproducibility is something that we need to be concerned about, and it's something that has not been given enough attention until recent years. So when we look at how non-replication works, there are several things that we need to consider. So the first, if my PowerPoint will start to work, it'd be better. So why would things not replicate? All right, so when we're looking at these, we're not looking at problems necessarily. Well, you got to think about the problem mainly as a problem that happened in the first study. This is normally what we're thinking about. But it could be a problem in the second study as well, right? The first is that some data was falsified. Somebody just straight up lied on the data. This is rare. It has happened in psychology, but it is rare. The vast majority of psychologists are not falsifying their data, but it has happened. And if you falsify data, then it's going to be really hard to replicate those findings because they're false. Another problem is statistical problems. When your sample size is small, you often have problems that indicate the problems just you can't find studies that you want. You can't find relationships that might be there because you don't have enough variability or variance to account for. There's other problems as well in terms of like being representative of the population, etc. However, if you have too many participants in your study, then almost every relationship is going to be significant if it's truly there. It's just going to have such a small effect size, but you have so many people in your study that you're going to find relationships that are super tiny and probably not as big a deal as people think they are. We've already talked about p-hacking. Now, p-hacking is when people do their statistics in a way, not intentionally generally, but they do it in a way that leads them to reject null hypotheses when they really shouldn't have done it because they've done too many studies, or they have collected data in iterations instead of doing a whole new study. Those are examples of p-hacking that have been done when they should not have been done. Another reason why things might not replicate is the change in a conceptual variable. So, for example, if there is a change in the way people understand humor, if you remember, we did the Strack et al. Study in 1988, where we put the pen in our mouth, or a pen in lips, pen in teeth. Well, if humor has changed since 1988, then maybe at the time in 1988 there really was a relationship between those, and maybe now there really aren't a relationship between your facial expression and something like humor. If those conceptual variables have changed, then you wouldn't expect it to replicate. This has been a particular problem when we talked about, in recent years, when people talk about the concept of stereotype threat, right? If stereotypes have changed over time, then we're not going to replicate those ideas in the same way. The last one is scientist error. So there's lots of different ways that scientists can make an error, and these could be just straight like clerical errors, accidentally put in the wrong data. It could be errors in connecting this condition with that condition. It could be any kind of error. Now, while we normally think about these as the original study making these mistakes, it could be that the replication could make any one of these mistakes as well. Hopefully, replication, though, is trying to be more precise and careful than even the original study did. So what do we do about it? What are we supposed to do about the replication crisis in psychology? Well, some things have been changing and become a lot better than they used to be. One is a change in priorities. One of the reasons why the replication crisis has been a problem, for those who really believe that it has been a problem, and most people think that we should be doing more replication, has to do with the way that things are published. It is very rare for us to publish non-significant results. So if you do a study and you get non-significant results, it's pretty certain that you're not going to be able to publish that. Now, sometimes you can, but it's really, really rare in psychology. It's really rare. Well, so why is that a big deal? Most studies in psychology get non-significant results. That's the way it works. And so more and more people are looking for the way that they can get things that will be publishable. And this might accidentally lead them to p-hacking, or into looking at things that they shouldn't, that really might not be that effective. But why are they doing this? Well, academic careers. You should know that in a research university, such as the University of Colorado at Boulder, this is a research university where the tenure track faculty, those who can receive tenure, assistant professors, associate professors, professors, they receive that tenure based mainly off of their research. Teaching does matter, but it's mainly off of their research. So academic careers are based off of how well you can do research. Well, how do you show how good of a researcher you are? By how many publications you have. Well, how do you get published? It's not by finding null results, and it's not by doing replications. Even when replications find significant results, it's not that interesting, right? You just say, oh yeah, it's the same as it was. Or you say, oh, I got null results, and nobody cares about those things. Most publications don't publish replications, whether they're null or not. And most publications don't publish null results. So people spend a lot more time looking for publishable studies where they reject the null hypothesis. And that can sometimes lead them into not very careful science, or it leads them to not try and replicate previous studies, which may have been type 1 error to begin with. Another way of getting around this has to do with registering studies. So more and more people are advocating registering a study. And what that means is, instead of doing the whole study and then sending it in and seeing if it can get published, which is what most people do today, instead what you do is you come up with your proposal of what you're going to do. and you register that. You say, this is exactly what I promise I'm going to do. And then some publications, not many, but some, will say, hey, that is such a good proposal that regardless of whether you get null results or significant results, we are going to publish it. And that way, people are sure that they're going to do exactly these things. And they register not only the method, but they also register their raw data and things so people can check on it. And by registering the study and being assured that the study is good enough to publish before they even do the study, people can be assured that they can get a publication and they can progress in their academic career. In reality, though, we have a long way to go to make sure that things are reproducible and to make sure that we are not basing our science on type 1 errors that have existed throughout time. All right. Thanks, everybody.